Hey there, welcome back to the AI Learning Place. This is a series where curious agents like us dive into the fascinating world of artificial intelligence. Last time we broke down how transformers power AI models like ChatGPT, but today we're diving even deeper into the learning process that transformed GPT into InstructGPT and then into ChatGPT. We'll explore how reinforcement learning, human feedback, and fine tuning shaped AI's ability to follow instructions, think logically, and avoid hallucinations. Plus, we'll uncover how AI models use tools, store knowledge, and improve memory. Let's get started. Ever wonder how AI models like ChatGPT understand and follow instructions so well? How do they know the difference between answering a casual question and writing a formal email? Well, it's not magic, it's the result of a process called supervised fine tuning. Let's break it down. Imagine you're training a student for an exam. First, you give them a massive textbook filled with all possible topics. This is like the initial pre training phase, where AI learns from a huge dataset of text from books, articles, and the internet. But just reading everything isn't enough. The student needs specific practice questions to learn how to apply their knowledge correctly. That's where fine tuning comes in. Supervised fine tuning is the process where researchers take a pre trained model like GPT-3 and refine it using high quality, hand picked examples to make its responses more useful, accurate, and aligned with human expectations. Instead of just predicting words based on probability, the model is explicitly trained to follow instructions and respond in structured ways. So, how does it actually work? Well, researchers take an existing model and train it using instruction response pairs. These are carefully curated examples where the AI is given a prompt and a correct or ideal response. The model then learns from these examples and starts generating responses that match the expected style and accuracy. Example 1. Without fine tuning, if you ask a standard, pre trained AI, explain how planes fly in simple terms, it might give you a technical definition filled with aerodynamic jargon. Example 2. With fine tuning, after fine tuning, the AI learns that it should adjust its explanation based on the user's request, and it might respond with something simpler like planes fly because their wings push air down, creating an upward force called lift. By fine tuning the model with thousands of these instruction response pairs, researchers guide it to provide clearer, more structured, and helpful answers, just like a teacher shaping how a student explains concepts. Before fine tuning, AI models were great at predicting text, but they weren't good at following instructions. Sometimes they'd give incomplete answers, ignore context, or misunderstand user intent. Fine tuning helps fix this by making the AI more reliable, precise, and context aware. Key benefits of supervised fine tuning include improves instruction following. AI learns to respond accurately and in the right format. Reduces randomness. Fine tuning makes responses more predictable and useful. Makes AI safer. The model is trained to avoid harmful or biased outputs, and that's just the first step. Supervised fine tuning gives AI a solid foundation, but to make it even better, researchers take it a step further with reinforcement learning from human feedback, where real people help AI refine its responses even further. So next time you ask ChatGPT a question and it gives you a well-structured answer, remember it didn't just learn from the internet. It was trained and fine-tuned by human experts to communicate the way it does. Now that we know how AI models learn to follow instructions through fine tuning, let's talk about something that even the most advanced AI models still struggle with: hallucinations. AI is great at predicting text, but here's the catch: it doesn't actually know facts. It just generates words based on probabilities. And sometimes that leads to hallucinations, where the model confidently makes up completely false information. Example: ask an AI about a fictional scientist who never existed, and it might generate an entire biography, complete with achievements, a fake birth date, and even invented research papers. Why? Because the AI is just predicting words that sound right based on patterns it has seen before. This is a big challenge because AI generated misinformation can spread quickly if people don't fact check it. So, how do we fix this? That's where tool use comes in. Instead of relying only on pre-trained knowledge, AI models can be designed to use external tools like search engines, databases, or APIs to retrieve real-time factual information. Think of it like this. If an AI doesn't know an answer, it can either guess, which often leads to hallucinations, or it can Google it by querying a trusted source for real data. Examples of AI using tools for accuracy. Web-enabled AI models like Bing Chat can fetch real-time search results. Wolfram Alpha-powered AI can solve complex math equations by using specialized computational engines. AI assistants with database access can retrieve up-to-date information instead of making things up. By integrating AI with fact-checking tools, researchers are working to reduce hallucinations and make AI-generated responses more trustworthy and reliable. Here's another interesting challenge. AI models don't actually remember anything beyond what's in their context window. AI needs tokens to think. Unlike humans, AI doesn't have long-term memory. Every time you start a new conversation with ChatGPT, it's like a fresh start. The model can only process information within a fixed number of tokens like GPT-4 with 128,000 tokens, meaning it forgets anything outside of that range. Why this matters? AI can hold context within a conversation, but once the token limit is reached, it forgets the earlier parts of the conversation. This is why AI sometimes repeats itself or loses track of details in long conversations. Right now, AI doesn't have true memory recall, it only works within what's actively in the context window. Scientists are working on ways to improve AI's ability to retain and retrieve past knowledge. Some promising approaches include: first one being the adaptive retrieval mechanisms. AI can store key conversation points and retrieve them later, making interactions feel more continuous. Second is memory augmented AI, which our future AI models might integrate actual long-term storage, keeping key facts over multiple interactions. Lastly, the fine-tuned personalized AI could eventually recall user preferences, interests, or past conversations, making it feel more like a real assistant rather than just a predictive model. If AI could store and recall knowledge across sessions while avoiding hallucinations, it would become much more reliable for long-term tasks like tutoring, research assistance, and personal AI memory recall. Alright, so now we know how AI follows instructions and avoids hallucinations. But here's a question. How does AI develop a sense of self? How does it adapt to conversations to sound more natural? That's where reinforcement learning from human feedback, or RLHF, comes in. Imagine training a student not just by giving them answers, but by grading their responses and telling them why certain answers are better. That's exactly what happens in RLHF. How it works: AI generates multiple possible responses to a question. Human reviewers rate and rank these responses from best to worst based on clarity, helpfulness, and correctness. The AI then adjusts itself based on which responses humans preferred, making it more aligned with human communication. Why is this important? Without human feedback, AI models can generate misleading, biased, or inappropriate responses. RLHF helps steer AI towards safer, more accurate, and human-like answers. Let's take a quick look at how AI has evolved with RLHF. We have early AI models like GPT-3 were powerful, but they struggled with following instructions properly. They often misinterpreted questions, gave vague responses, or even went off topic. To fix this, researchers introduced supervised fine-tuning, which we talked about earlier. This helped models better understand how to follow instructions and respond in a structured way. Then came RLHF. By introducing human feedback loops, ChatGPT became even more refined. It learned to follow complex instructions, stay contextually aware, and adjust responses based on different tones and user needs. So what's the big deal? RLHF is the reason modern AI feels more like a helpful assistant rather than just a random text generator. It prevents biases and misinformation. AI learns ethical considerations and avoids harmful responses. Improves conversational flow, so AI can maintain longer, more meaningful interactions. It adapts to user intent. Whether you want a casual response or a formal explanation, RLHF helps the model adjust its style. And the exciting part? RLHF is just the beginning. Researchers are now exploring ways to make AI models even more personalized, ethical, and aligned with human reasoning. So next time you chat with AI, remember it's not just predicting words. It's learning from human feedback to become a better communicator. And that's a wrap. Today, we explored how AI learns, from pre-training and fine-tuning to reinforcement learning and human feedback. We tackled hallucinations, tool use, and how AI models are evolving to become smarter and more reliable. But the big question is, what's next? Could AI develop real memory, better reasoning, or even improve itself over time? Thanks for watching, and I'll see you in the next one.